Hello guys, welcome back to new video. And in the last video we have discussed the part 3 of the projectile motion, and we were at the end we summed up the video at the point, uh, yes, this one point, like we tried out the formulas of v naught x and v naught y, and we got to know that these are very important formulas. In today's video what we are going to do is that we are looking into the horizontal motion and the terms related to that, and then we look into the vertical motion and the terms related to that. Probably we taking the help of this diagram over here. So for let me write uh, it over here. First of all, we are looking towards the horizontal motion. Horizontal motion, right? Horizontal motion. And furthermore, horizontal motion we will be discussing about uh, actually the horizontal motion over here is what is horizontal motion, uh, that is v naught x, actually v naught x. And if you're not known about what I'm talking about, like what is v naught x, to check out our previous video, you will get to know. Horizontal motion, which is on the x-axis, so that is v naught x. You can see over here that we are talking about this motion. This is over the x-axis, so that is the motion that is we can say v naught x or vx, or you can say simply in simple terms we can say that we are talking about the motion of the x-axis, right? We are talking about the motion of the x direction. And if we talk more about it, first of all let's discuss about uh, the displacement, horizontal displacement, horizontal displacement. Horizontal displacement, right? And what does horizontal displacement mean? What does it mean? Like uh, displacement means a displacement is a distance, like, and what is a horizontal displacement? This is the horizontal displacement from here to this point, like from the point of the initial point to the final point. The distance between them is termed as the horizontal displacement. There is a simple sense thing, like what is the vertical distance of it to what is the vertical displacement. You can say the area from here to here, that is the vertical, while this is the horizontal. uh, this is vertical and this is horizontal. So simply this is the thing. So displacement is kind of uh, what we say, this is kind of distance. So we like s, and s formula we know that s is equal to v into t, s equal to v into t, right? And in the case of horizontal motion or the projectile motion, the s is equal to, s is actually s, x in the x direction, like we are talking about x, and x is equal to, what is the formula of v in the case of projectile motion in the horizontal direction? That is v naught x, right? We have discussed this thing in our previous video. X is equal to v naught x into t. T is same, and here we have got our formula. uh, X is equal to v naught x into t. That is the formula for horizontal displacement of the projectile motion. Let's move for the second one, and now we are having horizontal velocity. Horizontal velocity. Okay, so if we talk about horizontal velocity means the velocity in the x-axis. So we can simply write vx, right? Vx, velocity in the x direction. We are talking about horizontal thing. So Vx is equal to, we are known in our previous video that in the x direction there is no force acting upon it. So that all depends upon the initial force or initial velocity. So Vx x is equal to v naught x, and v naught x is equal to is the initial speed or the velocity, because there is no force, and that is in the case of horizontal motion we have got the constant velocity in the x direction. So this is the formula. Now let's move forward. On the third point we have got uh, horizontal acceleration, horizontal acceleration, and we are not that if there is velocity is constant here, velocity is constant in x direction, vx is constant. Here is the term vx is constant because there is no force, like there is only air friction was there which is neglected, and there is no force acting on the x direction. There is a force acting in the vertical but no horizontal force, so the velocity is constant. And what about the definition of acceleration? So acceleration is the change, rate of change in velocity. So the velocity is constant, so how acceleration can be produced? So in this case ax, acceleration of x-axis, is equal to 0. Simply this is the thing, right? So I do hope that you've got this. Now let's move forward for the vertical motion. Number 2 we have got vertical motion. Vertical motion. Motion. Right. So first of all, let's discuss about the vertical displacement now. Number 1 we have got vertical displacement. I'm writing this for displacement, and for here we have got the formula, because here we have got vertical motion. So in displacement we have got the formula. You need to remember this. We have got the formula s is equal to, again you know, v is the s, and uh, v is the s, and now we have got the formula s is equal to v it from 1 upon 2 vat plus 1 upon 2 gt square. This is the formula from the Newton's law of motion. You need to remember this, that you are using this formula in the vertical motion. So s over here in case of a vertical motion, that is y, like, but it is x over here, so here it will be y because this is vertical motion. We are talking about the y-axis. So the displacement, vertical motion, uh, vertical displacement, in this diagram you can see that this I was talking about. So this is y, simply we are denoting it with the y, and it is from here to here. Okay, so y is equal to, that is now v naught y, v naught y, vi is equal to v naught, right? And what is the direction? V naught y, t plus 1 upon 2 and we have got gt square. Gt square is the same. Gravity is acting over there, the force acting over here is the acceleration acting over here is the gravity, right? So here is the formula for the displacement in the vertical direction. Now the second one we have got vertical velocity. Vertical velocity. Vertical velocity. Now if you talk about vertical velocity, you need to use the formula Vf is equal to Vi plus At, again from the Newton's law of motion. You can use the trick that in the case of vertical motion you are using mainly the formulas which are from Newton's law of motion. Like in the first we have used s equal to Vit plus 1 upon gt square, while in this one we are using Vf is equal to Vi plus At. Vi plus At not gt because gravity is acting over here. Like, let's write 80, then I will be converting it, right? Now what we will doing is that Vf in this case is Vy. It is not you know what we say, it is not V naught x in this case, or it is not V naught y, it is Vy. Vy is equal to v naught y, v initial, v naught y plus acceleration acting over here is gt, sorry, the g, that is value is uh, 9.8, and that is uh, what we say, that is negative, in a sense that is negative. Now here is the formula of vertical velocity, v naught velocity. Here in x we have got this one, and here y we are getting this one. Now let's move forward. Number 3 point, that is about uh, that is about the horizontal acceleration. Horizontal acceleration. Now in this case, uh, horizontal acceleration is equal to ay, and ay is equal to gravity, right? Gravity, acceleration, and gravity is a kind of acceleration, right? And to remember this, that we have got negative acceleration in this case. Let us discuss about why this is negative, but you need to remember this one point, like this is negative minus g. Here you're gonna see if this in this diagram. First of all, the body is moving, opposite. Gravity is this direction, uh, while this is moving into this direction. So this is a negative sign over here, right? And secondly, if you will say that in this direction it is going into this direction, why not positive? So the reason behind this is, like, in a way you can consider, like, if you still consider it from uh, you know uh, the velocity is decreasing and again increasing. So here it was max, here it was on neutral, here again increasing. So there is a shift, and due to the shift we have got signs are different. And probably I will be talking more deep into the negative g concept in the next video or any other video, hopefully. So this was kind of the values related to the velocities in the both direction, and hopefully in the next video we'll be discussing about uh, the more statements, more problem equations, formulas. So meet you guys in the next video. Till that, goodbye.